10. As I said, we're going to keep the end of topic tests for when we go back to school. I've had a look at the scheme of work and I've decided to reorder it just a little bit. So I'm going to skip chapter 12, which is similarity and congruence. That's about shapes and things, and I just think that's going to be easier to do kind of in real life. So I'm skipping on now to unit or chapter 13, which is called More Trigonometry. So this is chapter 13. For those of you keeping index pages and things, don't write that. It's More Trigonometry. We're going to start, so that's kind of like the chapter. We're going to start today by looking at the graphs of sine, cos and tan. So you'll remember, you'll have done SOHCAHTOA before with the buttons, the sine, cos and tan buttons on the calculator. We're going to look this week at the graphs of the trig functions. So this video is going to be about the graphs, and then there's going to be one more video this week about how we can use sine to work out the area of a triangle. And then next week we're going to look at something called the sine rule and the cosine rule. Remember, cosine is what cos is where cos comes from. So we're going to have a look at the graphs of sine, cos, and tan. So we're going to do this kind of backwards, actually. I'd like you to stop the video now and have a look at worksheet 1. So worksheet 1 asks you to fill in some tables of values, and then plot the graphs. So you're going to get a table, and it's going to have sine, cos, and tan. You're going to put those values into your calculator, and then you're going to draw the graphs. Okay. So just a reminder, you need to make sure you've got a capital D at the top. Now that's a D for degrees. It's possible that at the top of your calculator you have an R. Now an R stands for radians, which is a unit of angle measure that you'll do at A level. It's really important. You will get completely the wrong answer if this has got an R. So if you don't have a D at the top, you need to press Shift, and then you need to press the mode setup button, and then you need to press number 3. That gives you degrees. So just press 3 and that'll change it to a capital D at the top. Okay? So I'd like you to stop now, pause this video, and I'd like you to have a look at worksheet 1. Now just, I've made you some axes as well if you want to print them off, but you don't have to. So stop and have a look at worksheet 1, and then come back. Right, you're back. So, you should have now got what you think perhaps a graph of sine, cos and tan looks like. Now you need to know these graphs. You need to be able to just what we call sketch them. So you need to know their rough shape. You'll have got a pretty accurate one from your table of values, but you need to just be able to draw them very, very quickly. So in your grey book, you need to have these pictures drawn. I expect, or I anticipate, you'll have had a few problems with tan, because tan's a pretty crazy graph. But let's start with sine and cos. So y equals sine x. That's the graph that we're drawing. So draw yourself some axes. And hopefully you've noticed that the graphs don't go, or for sine and cos, don't go higher or lower than 1 and -1. So let's put 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and -1 on our graphs. And hopefully you've also realised that the important values, or the values that give us the most information, are 90, 180, 270, 360, and we could keep this going. So we could have, we could just keep this going forever. The graphs go on forever and ever. So I could have 450, etc., going up and up and up. And I could also have kept this graph going this way. So I could have -90, -180, etc. So the graphs go on forever and ever in the same pattern. So with any luck, hopefully you've seen that when it's 0, it's 0. When x is 0, y is 0. When x is 90, y is 1. When x is 180, y is 0. So we've got this kind of up and down situation. And then at 270, we've got -1. And then at 360, we've got 0. So what we get if we draw that, now remember, no feathering, commit to the curve. You find that we go up and we go down and we keep going down to -1 at 270 and we go up. And it's going to be that curve kind of on loop, as it were. So we're going to go up and down and down. And that curve would just keep going on forever and ever. And it's also the same in the negative. So it would be -1 at -90 and then it would go back up. You need to be able to draw that picture. You need to know that it goes up to 1 and down to -1. And you need to know that sine starts at 0, it goes up to 1 at 90, back to 0 at 180, down to -1 at 270, back up to 0 at 360. And you need to know that. You need to be able to just draw a sine graph. Okay, so you'll have a really accurate one from your table of values, but you should now also have this picture in your grey book. Okay? Right. And then we need to be able to draw cos. So we need to be able to draw the graph of y equals cos x. So for now, all we're going to do is learn how to draw them. That's all we're going to do with them. We will look at them and we will do a lot more with them, but for now I want you to just memorise drawing them. So dedicate 20 minutes today to just drawing these graphs over and over and over again. Okay? Right, cos. Let's draw the same axes. You'll probably find that drawing these graphs is one of the first things I'll get you to do next time I see you, be it in the corridor or on the court, on the tennis courts, wherever I am. I shall probably ask you to produce me some graphs, and we're going to use the same numbers. It's the same numbers, isn't it? That's important for cos. And again, we could keep going with those labels. Put a -90 on, like I did. This graph goes on forever. You could draw this graph just for the rest of your life if you wanted to. Okay, right, now hopefully you found that this graph is very, very similar. Your pen will find it a very similar shape to be drawing, but this time we start at 1. Okay, you might find it easier to maybe start here and then you can do the whole curve. Up to you. I'll start at 1. So we're going to start at 1. We're going to go down through 90. It's going to be -1 at 180. And then we're going to go back up through 270. And we're going to be back to 1 for 360. And then that shape's just going to keep going. Like that. Okay? And again, we could keep it going this way as well. Okay? So you'll see that these two graphs are really, really similar. In fact, if you pick up the cos graph and bump it along, you'll get the sine graph. So one is a translation of the other. You could say that sine is a translation of cos, or you could say that cos is a translation of sine. For now, I just need you to learn these graphs. Okay, that is a perfectly valid GCSE question. Just draw the graphs. Okay, right. Now tan, I imagine you have some pretty wacky tan graphs happening. So let's draw y equals tan x. I imagine some of you have got some extraordinarily wacky graphs because tan is a bit crazy. Can't really deny that. Tan is a little bit mad. So, hopefully you've found that there's some problems here. If I type in tan of 0, so when x is 0, I get 0. That's fine. If I type in tan of 45, I get 1. That's fine. If I type in tan of 90, I get an error. Now, that means that on our graph, we cannot have a point at 90. There's nowhere we can put a point to make it work, okay? So there's nothing we can do. We're going to have to not have a point at 90. And then we've got tan of maybe 135, that would be -1. And then we've got tan of 180, and that's 0 again. So we've got some important points that we can be thinking about. We've got a 0 at 0, and we've got a 0 at 180. That's important. How about 270? So tan of 270. Again, we get an error. And then I've got 360. So I'm breaking. I'm getting an error at 90 and at 270. Now in maths, if you can't have a point, if maths has broken at that point, graphically, that equates to us having an asymptote. So a line that you can never reach. So we're going to have an asymptote at 90 because it breaks at 90. There's no value that we can have. So remember, we represent asymptotes with a dotted line. So this line is what we call an asymptote. And it just means that it breaks at that point. Mathematically, tan does not exist at that point. And again, we got an error at 270. So we're going to have another asymptote at 270. And we'd have another asymptote in 180's time, and we'd have another asymptote later. So those asymptotes are going to repeat like clockwork. These graphs are really kind of like clockwork, okay? They're really, really regular. Nothing changes as you get to infinity. They're just going to do the same thing forever and ever. Where's my next asymptote? 450, which would be there. Right, so now all we've done is draw loads of dotted lines, which is exciting, but not very helpful. Right, so we know that it's 0 at this point. How about 89? What does it look like really, really close to this asymptote? Well, tan of 89 gives us 57. So it clearly isn't going to stop at 1, like the other two graphs have done. How about tan of 89.999? Well, look at that. So the closer we get to this asymptote, the bigger this is going to get. In other words, as we approach this asymptote, this graph is going to go to infinity. Right, let's look at the other side of this asymptote then. How about at 90.0001? Well, that's now absolutely massive, but very, very negative. So you can kind of see what's happening. We've got a graph that's getting bigger and bigger and bigger and bigger up here. And then it's going to get really small again. And then approaching this asymptote, it's going to get bigger and bigger and bigger. So we're building up a picture of what this graph's going to look like. In fact, our tan graph is going to look something like this. So it's a pretty crazy graph. And again, this graph will just go on forever and ever. Okay? So it's a pretty crazy graph, but it is what it's going to look like. Okay? So you also need to know that graph. Now that is probably the craziest graph you've ever drawn. And when we go back, we'll play around with autograph and we can draw sine and cos make really good hair for a smiley face on autograph. So there's tan. Okay, now for those of you that are wondering why tan breaks, I'm going to give you a little insight into A-level very quickly. At A-level, you'll learn that tan equals sine divided by cos. Now you don't need to know this. Okay, this is just for the people that are wondering why tan breaks. Tan equals sine divided by cos. Now look at cos. When cos is 0, we would be dividing by 0. And we know that that breaks maths. So we can't divide by 0. So it's going to break whenever cos is 0, which is at 90 and 270. And if you look, that's exactly where we've got these breaking points, these asymptotes, 90, 270, etc. So that's why it breaks. You don't need to know that. That was just a little bit of fun. So I'd like you to dedicate a little bit of time now to drawing those graphs over and over again. Get a bit of scrap paper, write on the inside of a cereal box. I don't mind where you do it, but I need you to just draw those graphs to the point where I can say cos, and you can just draw me a cos graph. Okay, so that's kind of the first half of this week sorted. Every morning I want you to just wake up and think, what a beautiful day, I'm going to draw some trig graphs. Okay, the second half of this week is going to be finding the area of a triangle using sine. Okay, so this is like a little standalone section. Please learn those 3 graphs. Get in touch if there's any questions. But again, they've just come from the table of values. So like if you wanted to draw, I don't know, the square root of x or x squared plus 9 or whatever, you could draw yourself a table of values like you've been doing for years and years. So hopefully you started this by doing worksheet 1, which was filling in the tables of values and drawing the graphs really accurately. Now I'm saying that all you need to know is that these graphs are fairly accurate. I haven't bothered plotting all of these points, but these are pretty accurate, and this is what you need to know. You need to know what these 3 graphs look like. And just to warn you, it'll be the first thing I ask you when I next see you, apart from, how are you? So, this is video 1 for this week, and whenever you're ready, you can watch video 2, which is going to be area of triangles. Anyway, I hope you're all well. You're going to have some beautiful notes from today, but I'd also like to see any disaster graphs. So anybody who committed to the curve and it didn't go quite right, send me a photo. Let me have a little smile. Right, I'll stop waffling. Bye.